This is 10.52. Calculate the density of sulfur hexafluoride gas, SF6, at 707 torr and 21 degrees Celsius. So density of a gas is equal to military police over rapid transit, MP divided by RT. So the molar mass would then be adding up SF6 on the periodic table. So if you add up 1 sulfur and 6 fluorines, it ends up being 146 grams per mole. And then the pressure, they tell us in the question, is 707 torr. And then the R you're going to have to use is for torr, so that would be 62.4 torr times liters per mole times kelvins. And then the temperature, of course, has to be in Kelvin. So 21 plus 273 would be 294 Kelvin. So check your units now. The Kelvin cancel with the Kelvin, the torr with the torr, the mole go with the mole, and we're left with gram over liter. So gram per liter is going to be our units for density. Multiply all those guys together, and we end up with 5.63 grams per liter for the density of sulfur hexafluoride gas at those conditions for letter A. Now in letter B, they ask calculate the molar mass of a vapor that has a density of, and they give us a temperature and a pressure. So this time we're going to use the same equation right here, but we know the density, we know the pressure, and we know the temperature, but now we don't know the M right here, we don't know the molar mass. So D is equal to MP divided by RT. We want to get M alone, so let's multiply both sides of the equation by RT over P. Do that same to this side. So then we end up with our molar mass equal to R times T times density divided by P, because remember, whatever you did to this side, you have to do to this side. And so then R, since the pressure is in torr, would be 62.4, and that would be torr times liter per mole times Kelvin. The temperature would be 12 degrees Celsius plus 273, so that would be 285 then kelvins. And then our density, they tell us, is 7.135 grams per liter. Watch those units. That has to be in grams per liter because you need your liters to cancel with your liters right here. And then you need grams per mole to end up being. And then our pressure is in torr, which is 743 torr. So you'll always be safe as long as you check your units, put them in, make sure that the torrs cancel with the torrs, the kelvins with the kelvins, and we're left with grams on top of a fraction and mole on the bottom of a fraction, and that'll give us our molar mass of grams per mole for our answer. So plug those into your calculator, and it ends up being 171 grams per mole.